Good morning, all. I hope you all are doing good. Now, in continuation to the previous video, let us go ahead with unit number 2, that is Color Standard and Digital Video from BA Electronics and Telecommunication Engineering, Solapur University, Solapur. So, in previous two video sessions, we have covered the television transmitter and receiver. This is specifically for monochrome, that is black and white, color television transmitter and receiver, then the concept of frequency interleaving, and then we have seen NTSC encoder and decoder. Now let us go ahead with what are the issues, problem with NTSC encoder and decoder, and how do we go ahead with the PAL encoder and decoder, followed by SECAM encoder decoder, and the comparison between SECAM, NTSC and PAL. Now this all part we have seen in previous video. Now NTSC encoder we have seen where we have used two kinds of signals, that is signal I and Q, and both these signals are mounted on the same carrier signal with the help of quadrature modulation. Now when we go for modulating two different signal on a single carrier, obviously we phase shift the carrier frequency by an angle of 90 degree, and then only we go ahead with the modulation. But still there are some phase shift related issue that will occur, and because of which NTSC encoder, whenever we use, they used to have some problem related to the phase shift error, and that phase shift error is eliminated in the next color system, that is nothing but the PAL system. Now PAL here stands for phase alteration by line. Now what is so different in PAL than that of NTSC? We'll just go through here. On the left side here we have the basic color encoder diagram, how PAL basically works. Now as earlier we have seen, there are two kinds of signals that we derive in NTSC, that is I and Q. Now in case of PAL, here we have two kinds of signals, signal U and signal V, which are the weighted signal. And what exactly we do here in case of PAL system is, if you can see here in this diagram, here the subcarrier will be generated, then the same subcarrier will be used for this balance modulator 1, where a signal U will be modulated. So it will be a simple modulation of a modulating signal and a carrier signal here. Now this we will be doing for line number 1, and then when for the same line, when we wish to go for the modulation for signal V, then what we will be doing here is the same carrier will be passed through a switch which is called as line by line switch. And here what has been done is, when the subcarrier frequency reaches to that switch, there will be a phase shift of plus 90 degree and minus 90 degree, and out of which the switch is going to be only at one position. Either it will be at plus 90 degree or it will be minus 90 degree, and that switch will be driven by a bistable pulses which is of 7812.5 hertz. Now 7812.5 hertz is nothing but exactly the half the frequency of 15625. What does this mean? Ki whatever the horizontal synchronization frequency that we use here is 15625, where each line will be will be getting scanned by a frequency of 15625. Then if we scan, or if we use the frequency exactly half of that, then instead of scanning every line, or instead of taking every line, every alternate line will be selected. So this way what has been done here is, in PAL system, one line will be scanned with or one line will be modulated with plus 90 degree and the next line will be modulated with minus 90 degree. Remember, we are going to do this only for signal V. So what has been done here is, there are let me summarize this. We have two kinds of signal here in PAL system. One is signal U, another is signal V. U signal is modulated as it is, that is without any kind of phase shift. But when we modulate a signal V, now what we have done in NTSC, that we have modulated another signal with plus 90 degree only. Now here what we are going to do is, the another signal which we are going to modulate will be modulated for plus 90 degree or minus 90 degree. Now when we modulate them for plus and minus 90 degree, obviously the basic requirement for quadrature modulation is there has to be a difference of 90 degree, so that 90 degree difference is maintained, so that signal will not get mixed with each other, and then plus 90 degree and minus 90 degree will be taken forward. Now the question arises, why to go for this? Why do we go for plus 90 degree and minus 90 degree for every alternate line? The solution will be given in the next slide here. Now just imagine this kind of diagram here, that once here you can see the U signal is modulated as it is, which is same as that of NTSC, and that is why it is called as NTSC line. Then there will be same on the same, for the same line we have signal V, which will be modulated for plus 90 degree. So here for first line N, we have U signal modulated without any phase shift and V signal modulated with plus 90 degree phase shift. Now when we move to the next line, then U will be modulated here as it is without any phase shift, while V will be modulated with minus 90 degree. So the 90 degree angle will be maintained, but only thing is that V will be having minus 90 degree phase shift. And when next line come, it will work as same as it is, that U will be without any phase shift and V will be with plus 90 degree. So this way if we go, then what ultimately we are going to achieve at the receiving end, or how the phase shift error will be eliminated, you can see here with the help of this diagram. Let us consider that it has an error delta, phase error occur in the signal in the form of delta degrees. Then for line number N, there will be a phase shift error of plus delta, and here you can see there will be a phase shift error of minus delta in N plus 1 line. And when both these signals with error, obviously there will not be elimination of phase shift error. Phase shift error will appear as it is, but when phase shift errored signal, when it traveled and reaches the receiving end, then if we check them on an average scale or average basis, that if middle line is here, then first line if we take, which has plus 90 plus delta error, and the next line will be having minus delta error, then if we take the average of both the errors, the error value will be eliminated, the error value will become 0. So in all, PAL system ensure that for first line a positive error will be generated, and with the next line negative error will be generated, so that when we take the averaging effect, or when we check the averaging effect at the receiving end, because let me give you a brief insight that whenever we have n number of lines, like in case of PAL system we have 625 lines, with the help of which we visualize the entire television picture. Now in whatever the screen size that we will be observing, you cannot distinguish between two simultaneous lines. So there are two lines, out of which one line is having positive error, another line is having negative error. Obviously to human eyes we will be observing the average effect of both the errors in line number 1 as well as in line number 2. And what exactly happening at PAL system is, PAL system is going to go for averaging of errors in simultaneously line, and that is why PAL system if at all error has occurred, it will be eliminated, or if at all error has occurred, it will be minimized or it will be removed completely. And that is how PAL system ensure that even if phase shift error occur, like in case of NTSC, that error will be taken care by PAL system. Now this is what the transmitter side of block diagram, which is obviously same as that of NTSC system, where whatever the CCVS signal, that is composite color video signal, which is combination of Y, that is luminance, which is combination of luminance, then C, that is chrominance, then CB, that is color burst, and the synchronization pulses. The entire CCVS signal will be given to the amplitude modulator, and then modulation will took place, and then after amplification, filter, and the addition with the audio signal, the signal will be transmitted through air with the help of antenna. That is how the basic block diagram of PAL color encoder, or how PAL color encoder works. Now let us see in detail how exactly this PAL encoder detailed block diagram look like. Now here in front of you, though the diagram look good, look big, it is not that difficult. Just go through step by step. It will be very easy for you to understand. Like here we have R, G and B signal. Obviously whenever we go for color television, the output will be getting in the form of the voltages of VR, VG and VB only, but we are interested in U, V and Y signal. So from there will be a matrix with the help of which we will be getting the signal Y, U and V. Then the Y signal will be passed through a delay line, and there will be an adder, to which obviously after certain processing on U and V, the signal will be met, that is nothing but your chrominance signal. Now let us see how what are the other details that it has. Now we require here a color subcarrier generator. Now here it is, the color subcarrier generator, which will be generating a frequency of 4.43 megahertz. Now remember, in case of PAL, the video signal bandwidth is 5 megahertz, and the total video signal bandwidth is 7 megahertz after modulation. Now here we keep the color subcarrier value, the central value of the color subcarrier, exactly at 4.43 megahertz. Now around which signal U and signal V will be there. Now this color subcarrier will be giving input to a switch here, which is plus minus 90 degree both the sides, and which will be driven, the switch will be driven by an multivibrator of 7.8 kilohertz of the signal, where which is exactly half of that of horizontal synchronization pulses, so that it can get the exactly 50% value or every alternate value of the horizontal signal. Then given to a balance modulator for V, and without passing through a switch, directly signal is given here to the balance modulator U. So this way we have here a FSC at an angle 0, and here the subcarrier frequency at an angle of plus or minus 90 degree. Then output of both will be a chrominance signal, which will be added together here. Then after passing through a filter, it will be added here. Now here we have, from this side we have here signal Y along with some synchronization pulses, and here we have a chrominance signal C. Then obviously there will be amplification of the signal, and then it will be transmitted to the main transmitter, and this is how a PAL encoder works. Now this is PAL decoder. Now whatever has happened at the transmitter, we need to go for exactly the reverse process. Now transmitter side we have already seen in NTSC. Almost the working will be exactly the same. There are few blocks which will get changed. Now here, once we get the signal from the video decoder circuit, that is nothing but video circuit will be separated out. Then the sync pulses will be separated. Then we have a block here called as AGC circuit, which is nothing but the automatic gain control. Now why do we require an automatic gain control here? Now that is required for every television receiver side, let it be PAL, NTSC or SECAM. Automatic gain controller is must, which ensures that whenever signal come back by after striking every possible ways, the amplitude value of the signal should remain same. That is because video signal is nothing but there are changes in amplitude values of every signal depending upon the brightness value, depending upon the color value, the amplitude continuously changes. But if one signal have multiple if it strikes multiple trackles and then it reach back to the antenna, it may happen that its amplitude level may get down. So we need to ensure that, an AGC circuit need to ensure that irrespective of how many obstacles it has struck, whatever the gain value has fallen down, AGC will ensure that the every signal will reach back to its original value. Obviously that will be an relative value, and for that AGC will ensure that it will compare the amplitude values with the horizontal blanking pulses, which never get changes. It's almost remain at the height of 75%. Now we have here horizontal oscillator circuit, because once we separated the synchronization circuit, we take out the horizontal as well as vertical oscillating pulses and we pass it on to the picture tube, where we need to get driven the horizontal as well as vertical deflection circuits. Now once this burst blanking pulses get separated out, with the help of that blanking pulses, we will run loop here. Now here you see there is a PLL circuit combining these 3-4 blocks, where the color subcarrier frequency will be taken as a feedback, and a subcarrier oscillator will be generating the exact frequency which it has generated earlier, that is 4.43 megahertz. And until unless the frequency matches, until unless the phase matches, the signal will not be transmitted to the switch, electronic line by line switch. Now once this line by line switch is used, it will be giving input to this regulator. For V it will be for plus or minus 90 degree, and for U it will remain unchanged, that whatever the carrier signal is there, it will be given as it is, so that from the output of both the demodulators will be getting signal U and signal V. Once we have the value of signal U and V, from them we can derive the value of B minus Y, G minus Y as well as R minus Y, because Y value we have already derived here. So that once we have all these values of B minus Y, R minus Y and Y signal, we can easily fetch the value of R, G and B, and even Y is already been there. So if monochrome television is there, only Y will come into the picture, and if color television receiver is there, then we have to go for values of R, G and B, which will be given to the respective the electron gun for R, electron gun for G and electron gun for B. And this is how and PAL decoder work. Now PAL, if you compare with NTSC, obviously NTSC altogether is a different system, because NTSC work with 525 lines. Its operating frequency is different for vertical scanning. Then it will be using a different altogether methodology. But in NTSC, in early days, the phase shift error has occurred. NTSC, it is mostly preferred in American subcontinents, and in America there was an hardware tool which has been derived to ensure that if at all phase shift error occur, that error will be eliminated. So it's nothing like NTSC is better or PAL is better, but after NTSC been studied, it has been launched, a PAL system was there into his early days. So PAL has taken over that. If error has occurred in case of NTSC, so that phase shift error can be eliminated in case of PAL system, and that has been used in the Germany as well as in Indian subcontinents, or like in Asian subcontinents. Now let us move, like we have seen NTSC, we have seen PAL. In both the system, phase shift is error is going to get happen for sure. Now NTSC, it used some hardware mechanism to get rid of the phase shift error, while PAL ensure that phase shift error let it occur, but it will be occurred in positive way for one first line and negative for second line, and average of both the errors will be taken, so that the effect of phase shift error can be minimized, or it can be removed completely also. But obviously in both the systems which supports a very high level of risk of having the phase shift error. The next method which has been suggested, or which has been suggested by the French, or which is called as a French standard, mostly used in Russian ways, in French, that is nothing but the SECAM standard, which called as sequential memory, where the working is completely different than that of PAL as well as NTSC, because PAL and NTSC, many things are in common, that both of them go for quadrature modulation. But here in case of SECAM, completely complete new methodology has been preferred, that in case of SECAM, audio signal is amplitude modulated, while a video signal is frequency modulated. At the same time, there is one more methodology that has been adopted, is the color subcarrier which we have used. So color subcarrier, we go for quadrature modulation, which means like both the color difference signals been transmitted on a single carrier, while in SECAM what has been done is, whenever we go for combining two signal on the same carrier, obviously there may result some kind of phase shift error, and in order to eliminate that, SECAM ensure that if the carrier is single, there has to be a single modulating signal only, and that way the phase shift error problem it has completely eliminated. Now how it has been, how is it possible? Because if we go for the color signal or chroma signal, it is combination of both, that is R minus Y as well as B minus Y, that is two kinds of color difference signal are here there. And same in case of SECAM, we have two kinds of signal, that is DR and DB. But a color subcarrier, only one color subcarrier is to be used for transmitting one signal only, then it is not possible to generate or regenerate the original color with the help of only one signal, which means that we need to send two signals. But SECAM standard suggested that one carrier, one signal. So what has been done, or what solution which is given by SECAM is, it as it says, it will transmit one signal on a single carrier only, but at a time, and when next line comes, on next line it is going to transmit the next signal. So in short, what has been done in SECAM is, from the matrix of R, G and B, with the help of a matrix from signal of R, G and B, it has generated three signals, that is Y, DR and DB. DR stands for the color difference signal for red and color difference signal for blue. Then both there use a one electronic switch, which is a line by line switch, which ensures that for first line DR signal will be transmitted, and on the on the next line DB signal will be transmitted, so that whenever a color subcarrier is generated, like here a color subcarrier is generated, now with the help of this color subcarrier, certain filters are used here, so this DR only will be modulated for one line, and when next line comes, this dB will be modulated and transmitted through air. Now and obviously Y signal will be here after delay line, it will be added together and a composite chrominance signal will be generated. So other working is exactly remain same, but only thing is in case of SECAM, at one time we will be transmitting only one color difference signal. Now with this the transmitter part become very easy to use. Transmitter to understand is also easy, as well as to transmit the signal, to deal with the power and everything looks very good. But when it comes to the receiver become complicated. Why? Because no, it does not matter when how you're transmitting the signal one at a time or one by one, but at the receiver's end, whenever we have to reproduce the original color, we need both the signals to be there present at a time. So but what we are doing is we are transmitting one color difference signal in first with the help of with first line, and another color signal with the next line. But at the receiver we need both the signals to be remain present at a time, so that we can reproduce the original color. And in order to solve this problem, as the title itself indicates, it is SECAM, stands for sequential memory. What does this mean? It means at the receiving side, SECAM uses a memory element which stores certain amount of data. Now what has been done in SECAM receiver is there will be a memory device which will be saving, which will be storing a one line information. For say for example, initially we are transmitting dr. So once dr is transmitted, at the receiving end the dr value will be stored, and whenever the db value comes, then dr and db will be processed simultaneously. So it will be storing certain value with itself in a memory, and with that memory element will be available at every receiver. And that is how a SECAM system works. Now here you can see in the diagram itself, the encoder, the transmitter side looks very easy, and this is how the SECAM decoder look like, where, as I say, this is an 64 microsecond delay line, which is nothing but a memory device, because one line value or one line information we transmit with the help of 64 microseconds only. And so in short, this signal will be stored for 64 microseconds, which means it will be storing that particular line information only. So here, whenever the composite signal comes after certain filters, when it reach back here, one signal will be processed as it is here till here, but the same signal will be stored here for 64 microsecond of the time. Now when, say for example, dr is here, so dr here will be stored for one line information, that is 64 microsecond, and the dr value will reaches here. Now first dr value it will ignore. Now when next 64 microsecond comes, or next line information comes, from this side db will be here. So db will reach here immediately, while dr will reach here after 64 microsecond of the time, which means one line information. And the switch is so connected that this is 1 and this one here is 2. So both the side here we will be getting the value of db, and here we'll be getting the value of dr. So this way the one line information or this memory value will ensure that this memory value will ensure that the signal will be stored at the receiving side for one line information, and it will be used whenever the next line information comes. And this way SECAM system ensures that the transmitter side or encoder sides, the complexity can be saved, phase error can be eliminated by increasing a little bit of complexity at the receiving side. And that is the reason why SECAM is nowadays become much more popular. Even in digital transmission of the signal, we prefer to go ahead with the SECAM. And again, as I said, the same here, the demodulation took place from this side. Again demodulation took place, amplification. So here we have dr, here we have db. from this side y signal will be there, and when both the DRDB and y signal is there, it is very easy to go for a matrix to derive the signal of VR, VG and VB, and these signals can be given to a picture tube to observe to see a color picture without any kind of phase shift. So SECAM ensure that a phase shift error can be eliminated and the television no color change or true color information can be observed. Now this is what the differences between the PAL, SECAM and NTSC. Now the PAL, as it is originated in Germany, NTSC SECAM, and here SECAM NTSC is in USA and SECAM is in France. PAL, it stands for phase alteration by line. Then NTSC is National Television System Committee. Obviously, it is in United States, and SECAM, it is okay. It is wrongly printed. It is actually sequential memory. Now, countries where it has been used, as I said, PAL is used in Germany, India, UK. NTSC is in USA, Canada, Japan, Mexico, and SECAM is in France, Africa, on certain Eastern Europe side. Now transmission of color, all of them go for transmission of color difference signal. Nobody is transmitting the data R, G and B. Now video signal bandwidth, as per as concerned, we have 4 megahertz of this video signal bandwidth for NTSC because it is an 565 line standard. We have PAL for 5 megahertz and SECAM for 6 megahertz. And some cost and identification of the signal, and this is how the comparison with NTSC, PAL and SECAM goes. Next bit here is color burst signal. Now we have already discussed this out in the previous videos, but let us just quickly finish it up. So color burst signal here is nothing but 8 to 10 cycles of the color subcarrier which is transmitted along with the luminance signal at the back porch. This is what the definition of color burst. But what exactly this color burst is? As I told you earlier, in case of NTSC as well as PAL, we are not transmitting the color, rather we are suppressing the color subcarrier frequency in order to save the power. The color subcarrier frequency is suppressed, but in order to reproduce the original frequency, that is in case of NTSC it is 3.58, in case of PAL it is 4.43, to ensure that exact frequency which has been generated at the transmitter side, we have to generate the same frequency at the receiving side also, and not only frequency but the same phase is to be again generated. So we need certain amount of signal, certain amount of samples of that signal. So burst signal is nothing but the samples, 8 to 10 samples of the color subcarrier signal. Now generally we have a synchronization signal here used in luminance signal. In luminance we have horizontal as well as vertical blanking pulses, but we have ample amount of space available in horizontal blanking pulses in back porch, which is almost 5.8 microsecond of the time period, which is blank only, and in that blank period only we transmit this, we fit this color burst signal, and that is how a color burst signal is transmitted. And the same color burst signal help as in feedback to color subcarrier generated at the receiving side, so that original color subcarrier signal can be generated and the job of demodulation become easy. And this is how a color burst signal is. Now this is all about chapter number 2. Now we'll soon meet with chapter number 3 and chapter number 5. So thank you very much, and keep taking care of your health. Thank you.